Hello, Math 2 Extended. I'm Mrs. Bricky, and this video is for Unit 2, Lesson 2, Solving with Radicals. So I have a little equation right here with this empty box, and I'm wondering what two values can go in that box. Well, right away, probably what most people think of is 4, because they know that 4 squared gives you 16, but you are a sophisticated math student, so you probably also realized that if we square -4, we get 16. So those are the two values that could go in that box to make that equation true. So whenever we're working on solving equations that contain an exponent of 2, we want to use the square root to undo that power of 2. But as we apply the square root to both sides of the equation, we must insert a plus or minus symbol because we know that there is both a positive and a negative value that will give a positive result when squared. So when we apply the square root to both sides of our equation, we insert this plus or minus symbol. Woo, sorry. We insert this plus or minus symbol. Now that plus or minus symbol is just shorthand. It's just shorthand for the fact that we have two answers here, positive 11 and negative 11. So plus and minus 11 is just saying we have both a positive and a negative 11 as our answer. So if you prefer to write it like this, you absolutely can if you like, but it's pretty customary to just use that shorthand to report your answer. So these sort of equations can have all types of solutions, not just whole numbers like 11. So let's look at a few. This first one is x squared equals 529. So if we apply a square root to both sides of the equation, we want to remember to insert our plus and minus symbol. And if we take the square root of 529, we get, I guess I need my calculator, 23. So in other words, this equation has two answers. If we square 23, we get 529. And if we square a -23, we get 529. So both of these two solutions work, and it is two solutions, a positive 23 and a negative 23, just written with shorthand. All right, let's try the next one. We apply the root to both sides of our equation. And if you type that root 15 into your calculator, you will just get a root 15 back. And again, in this class, we don't really want to go into decimal approximations unless we're doing some kind of word problem, and then it will tell you to round. In this case, we're just going to leave our answer in that exact radical form. That's just an irrational answer. So this is two answers. We have two solutions. X equals positive root 15, and also x equals negative root 15. Okay, the next one, we're going to apply that square root to both sides of our equation, and we get x is equal to, and if you let your calculator simplify that radical, you get 10 root 2. The square root of 200 is the same as 10 root 2. So another question that had two irrational answers, but this time they have a coefficient of 10, so x is equal to positive and negative 10 root 2. All right, our last one. This one's going to enter us into our new number system that we learned last time. X is equal to, and if we take the square root of -64, we're going to get an error in our calculator. That's because it's an imaginary answer. So we need an I in our answer. And the square root of 64 is 8. So our answer is positive 8i and negative 8i. So again, this is just shorthand. We have two answers, positive 8i and negative 8i. Sometimes our equations are a little bit more complicated and we need to do a little bit of work before we apply the root. So if you have extra things in your equation like coefficients or numbers that are being added, you really need to take care of those before the square root. So in this case, I would start by subtracting 12. That gives us 4x squared equals 100. And then we would divide by 4 on both sides, and that will give us x squared is equal to 25. Now we have this square right here. We have that isolated. It's all by itself now. So now we're ready to apply our square root to both sides. When we're solving equations and we apply a square root to both sides of our equations, we need to remember we have a positive and negative answer. Our equation has two solutions. In this case, they are positive and negative 5. Okay, this next question, we've got our square right over here. We need to isolate it. So we've got a couple of things happening. We have a 4 that's with it, and we have a negative 7. So we're going to start by subtracting that constant of 4. So we get 182 is equal to negative 7x squared. We're now ready to divide by negative 7. 182 divided by negative 7 gives us negative 26. And we're ready to apply our square root. Now, if it bothers you to have the x on the right side of the equation, you can always switch sides if that makes you feel more comfortable. I'm going to continue working with it on the right, but always you can switch if you like. So we're going to apply the square root to both sides of this. We need our plus or minus symbol. I'm going to put it on the numeric side, not with the x, but with the number. If we evaluate root 26 in our calculator, it is root 26, but this has a negative under the root, so we know it's an imaginary answer. So we have plus or minus I root 26 is equal to x. For the sake of the video, I'm going to skip this next problem and go to the last one here. You may even have instances where you have x squared showing up several times in your equation. You still want to just work on that equation until you have isolated the squared term. So in this equation, you would maybe notice that on this side, you have a 4x squared. We have a 1 and 3 more. And you could combine them in a separate step if you wanted, or you can just maybe notice that. So I'm going to subtract 2x squared from this side of the equation. And I'm going to go ahead and add the 31 to the other side because I know I want my variables on one side and my constant on the other in this type of equation. So this term cancels out. Negative 7 plus 31 is 24. This term cancels out. And again, be careful not to lose this one. I have 1x squared plus 3x squared. That's a total of 4x squared, and we're subtracting 2, so that's 2x squared. I'm going to highlight those x squareds in case you can't see where they all came from. So when we combine those up, we get 2x squared. Okay, now we're going to divide both sides of our equation by 2, and we're almost there. We have 12 is equal to x squared. Our final step is going to be to apply a root to both sides. And the square root of 12, I'm going to let my calculator evaluate that. It's 2 root 3. Oh, I did the weird plus and minus on the x side. I kind of get used to that, and you probably will too. I get used to having it on the right, but I should put it with the numeric side. Okay, so positive and negative 2 root 3 is equal to x. And that would be our solution. So before you start this next section of the video, if you have your assignment or if you need to look on Canvas to get the assignment, you should try the front side of the assignment. The front side will have equations similar to the ones that we just worked now. If you're at home and you don't have the physical paper copy of that assignment, you're welcome to just look at the PDF of the assignment on Canvas and write your work on a separate piece of paper and turn it in. Just make sure you label it as assignment 2.2, or you can get the assignment from me when you're back at school. Okay, this is another type of equation that we're going to work on solving today. So I want to talk about a little bit about how we're going to deal with these binomials this unit in this lesson versus how we did last unit. So last unit, we would have a binomial squared, and our goal would be to multiply it out, and we would turn it into, in this case, x squared plus 6x plus 9. And that was our goal, was to just put that expression into standard form. Well, we aren't working with expressions anymore today. Today we are working on equations. So when we work with expressions, we sometimes want to change the form of them. When we work with equations, we have two sides of that equation that we can manipulate and we can choose to do different operations on. So we do not want to multiply out in this unit. We aren't working with expressions and we don't want to multiply out. We want to apply roots. So as we work with these equations, our goal is going to be to isolate the root, or isolate the square, I'm sorry. So here's my square. I have an x plus 3 that's squared. Well, if my goal is to isolate that square, then I need to add 5 to both sides of my equation. That gives me the equation x plus 3 squared is equal to 16. Now I'm ready to apply the square root to both sides of that equation. When I apply a square root to both sides of the equation, I need to remember that there are actually two answers, a positive and negative answer, and so I use that plus or minus symbol to help me keep track of those two answers. Okay, so on the left-hand side here, we have something that's squared and rooted. So squaring and rooting undo each other, so this leaves me with x plus 3. And then on the right side, I have positive and negative root 16, and we know that the root of 16 is 4. So I have this equation, x plus 3 is equal to positive and negative 4. Well, what you want to do in this case is you need to separate this into two equations, because that really is what it is. It's just written in shorthand. So I'm going to write my first equation, x plus 3 equals 4, and my second equation is x plus 3 equals negative 4. You don't want to just start subtracting 3, because you have to remember that this is two different numbers. It's a positive 4 and it's a negative 4. When we subtract 3 from 4, we get 1, and that is one of our answers. But when we subtract 3 from negative 4, we actually end up with a second solution of negative 7. Those are our two answers to this equation. Either x is equal to 1 or x is equal to negative 7. And this is a little bit tricky at first, so keep practicing it. You'll get the hang of it. I want to try another one with you in the video, and then we'll look at some other possibilities that are going to come up. We want to isolate our square. So our square is right here. It's an x plus 10 squared. And we need to peel back the layers of that equation and isolate it. So I'm going to start by adding the 37. I wouldn't want to start, I'm going to show you what sometimes people want to do. I wouldn't want to start by dividing by 2, because that 37 would also have to be divided by 2. And now I'm in fraction world, because 37 divided by 2 is not a nice number. So we do want to go ahead and add the 37 first. So add the 37. And 13 plus 37 is 50. Now I can divide by 2 to isolate that root. So I have x plus 10 squared is equal to 25. When I apply the root to both sides of this equation, I need to remember to insert my plus and minus symbol, because we have two solutions, a positive and a negative. So that right side of the equation is positive and negative 5. On the left side of the equation, the power and the root cancel each other out, and we end up with an x plus 10. Now, this is a point where we need to separate into two equations. So we have x plus 10 is equal to 5, and we have x plus 10 is equal to negative 5. So to finish solving for x, we need to subtract 10 from both sides of our equation. So in this case, we get x is equal to negative 5. And in this case of the second equation, we get x is equal to negative 15. So we can have two answers that are negative. We can have two answers that are positive. It really just depends on the structure of the equation. The 5 right here was where I had the positive and the negative. And then from there, I did some stuff to it, and it became this negative 5 and this negative 15. So don't be worried if you're like, wait, I should have a positive and a negative. That is not always the case. We do have a positive and negative come up in our equation, but that's maybe not our end position. Okay, let's try this one and see how it is different. Now, I already have the square isolated on this one so that we could save some time on those extra steps. So we're ready to apply our root. When we apply the square root to both sides of this equation, the left side of the equation becomes x minus 7. And on the right side, I have positive and negative root 60, which if we simplify that root 60, it becomes 2 root 15. Now our goal is to solve for x, and what I've had you doing in the past on an equation like this is separating it. So I want to talk about what happens when we separate it. So I have x minus 7 equals positive 2 root 15, and I have x minus 7 is equal to negative 2 root 15. Well, to get the x alone, or to solve for x, I need to add 7 to both sides of this equation in both cases. So on this side, I end up with that I have these two things that I'm adding together, and the two things are a 7 and a 2 root 15. But because this part of it is rational and this part of it is irrational, they can't really combine. Now, we could figure out their decimal equivalent. We could type this into our calculator and get a decimal. That decimal it's about 14.746. So it's definitely just a number, but it's the number 7 plus 2 root 15. On this other equation, if we add the 7, we have two things that are being combined, 7 minus 2 root 15. But again, since one of them is rational and one of them is irrational, our calculator and our own brains, we can't really combine them. We can get a decimal approximation from our calculator, though, if we want. 7 minus 2 root 15 is negative 0.746. So you might notice when you look at these two that they're almost the same. The only difference is that sign. So when we report our answer, we usually report it in shorthand like this: 7 plus or minus 2 root 15. In this class, that's the sort of answer we prefer to leave it in, this form that we prefer to leave it in. But I really want you to understand that that is just two numbers. It is the number 14.746, blah, 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 and it's the number negative 0.746, blah, blah, blah. If I looked on a number line, 7 is right here, and the two answers are 2 root 15 away from 7 on both sides. So that's what the 7 plus or minus 2 root 15 is really saying. It's saying, that 7 is sort of our center, and we're at 2 root 15 on each side of 7 to get those two answers. Now again, this is probably the way that we will always want our answer reported. I just want you to understand what that means. Let's try another one. We kind of already talked about this. Sorry, I forgot the slide was here. So again, if you have an irrational part that's added to a rational part, we don't combine them, we just leave them separately. If their radical part is different, they also can't combine. An instance in which you could combine is something like this, where they both have that root 15, and we definitely could combine this into a 9 root 15. And your calculator would show you that these can't combine and that these can if you type it into your calculator. This idea is very, very similar to our ideas when we're adding polynomials and combining like terms. If they aren't alike, they don't combine. Only when they're alike are we allowed to combine them. And that sort of works, that principle works with radicals as well. Okay, in these sorts of equations, imaginary numbers can come up too. So we're going to solve these two equations for x. Remember, our strategy is that we isolate the square and then we apply the square root. So I'm going to start by subtracting 4. Now we're ready to apply the square root to both sides of our equation. Don't forget your plus and minus symbol when you do that. On the left, we now have x minus 5 because the root and the power undid each other. And the square root of negative 4 is an imaginary number. It's the imaginary number 2i. Now to finish up solving this equation, we need to add 5 to both sides. Now, we've been separating it in the past, and you definitely want to separate it if it's integers, but in this case, I'm going to write out what it looks like if I separate it. If I separate it, it looks like this. And when I go to add 5, I'm adding a real number, 5, to an imaginary number, 2i. So just like with roots, those can't combine. It's not going to be a 7i. It's just going to be a real number 5 plus an imaginary number 2i. Those parts can't combine. So our answers look like this. So usually we don't separate it because we know that those two parts aren't going to combine. We usually jump straight down and say, okay, my answer is a real number 5 plus or minus an imaginary number 2i. And it is pretty customary to put that rational part first and then put that imaginary part second with the plus or minus symbol in between. So we're going to try one more of those. This one, x plus 7 squared is equal to negative 80. And again, I have this one isolated for us already, so we're ready to apply the square root to both sides. Don't forget your plus and minus symbol. We've got two answers that we need to seek out. On the left, we have x plus 7, and I really don't need a parenthesis there because the root and the power undid each other. So we just have x plus 7. And on the other side, I have two things, a positive and a negative. And the square root of 80 is 4 root 5. This is going to be 4i root 5 because it is the imaginary, an imaginary number. So now we're ready to do our final step, which is subtracting 7. The 7 can't combine with the 4i root 5 because it is an imaginary number. So our final answer would be negative 7. We usually put the rational part first, plus or minus 4i root 5. And that is a funky answer, but that is it. That's the number that makes this equation true. So as you're solving these equations, they all look really similar to start with, but your results and your answers to these will vary a lot. For some equations, you end up with a positive and negative irrational number. For some of them, you end up with an imaginary number. You may end up with two integers. You may end up with an imaginary number that has a rational number with it. something really complicated like that last one we solved. It could just be an irrational number. So, any of these types of answers are going to come up. And the real key is to deal with the radical carefully, so that you get that radical simplified, and then to know when you can combine things up or when you just have that positive and negative answer, and when you have to leave your parts separate, like on this one or on this one. So I think, practice it, work on that back page of the assignment. And if you are struggling, let me know and we'll just keep working on it. But I think you're going to be an expert in no time, even though these do sometimes seem at first ridiculously complicated. Anyway, let me know if you're having any troubles. Thanks for watching the video and staying caught up in class.